Hello learners, my name is Mr. Paul Chilola once again, your physics teacher. And let me particularly invite the Cambridge students as well as the students from other curriculum to gather here. We are looking at a physics paper. I would like to go through physics paper 1, which is a core paper. All right. So just some preliminary information. This paper is to be done in 45 minutes. If you were to sit for this paper usually is 45 minutes long. And it's a multiple choice. Okay. Right. And also take note that it contains 40 questions. Okay, so we have 40 questions to be done in 45 minutes. That means roughly you need to spend the time you need to spend per question is 45 divided by 40, that's roughly 1.125 minutes. That's not enough time. That's why you need it to be fast and accurate in your responses. Fast and accurate, so that by the end of the 45 minutes you are almost done. All right. It is important to be accurate so that if the time to stop is called out before you finish, those questions that you have attempted, you have gotten them right. And I would encourage you that your speed should be such that by the time to stop is called out, you should be able to answer more than 30 questions. So answering more than 30 questions, suppose you answer 30 questions, it means if you happen to get all of them right, then you have 75% pass. That's good. That's quite indicative. It indicates that you've done a good job there. All right. And good enough. We are allowed to use a calculator. So make sure you have a calculator with you. Right. And the total is 40. So your paper is marked out of 40. Out of 40 marks. That means each question is worth just a mark. And for questions that require us to use the acceleration of free fall, which is in most cases called G, we are told to take G as 9.8 meters per second squared. Gravitational field strength of 9.8 newtons per kg. This is the additional information that we are given. So please take note of this. All right, so that's what we have. So without further ado, let's look at what question number 1 is asking us to do. So we are told that the diagram shows an enlarged drawing of the end of a meter ruler. It is being used to measure the length of a small feather. So we have a small feather here, which we have to determine its length for. All right, so first of all, check the ruler is is calibrated in millimeters, as you see. That means each small division or the least count of this ruler is 1 millimeter. Okay. All right. So in order to determine the length of the feather here, we just have to take note of the readings at the end of each end of the feather. So over here, the reading here is just a minute. Let's choose ready. Okay. So we are saying the reading here is 10. So we have 10 millimeters. And over here, this is roughly 29 millimeters. That means the length is going to be 29, subtract 10, which is 19. So 19, that means the option is A, the correct option is A. Okay? So that's the reading, that's the length of the bird feather. Number 2, the diagram shows two objects, X and Y. So we have X and Y here. They are suspended from identical springs. The extension of each spring is different. All right? Okay. So which row compares the mass and the weight? Which row compares the mass and the weight of the two objects? So we are told one thing is that the springs are identical. If the springs are identical, what that means, they have same metal, type of metal, and therefore same spring constant K. Okay. Now remember that the extension of the spring depends on the weight. Okay. The bigger the weight, the more or the greater the extension. So compared to X, this has a smaller extension. Let's call this extension 1, and this one extension 2. So in this case, we are saying extension of X is less than extension of Y from the look of things, because Y is longer than X. So that means X must be less, the mass of X, the mass and the weight of X must be less than the mass and the weight of Y. All right, so let's look for the options. In A is saying that okay, option A is saying both objects have the same mass. That cannot be, because already the springs, if the masses were the same, it means the springs would be extended by the same magnitude. Okay, both objects have the same weight. No, so it cannot be A. B is saying both objects have the same mass. Already we have said no to the first one. Even if this may be true, the weight of X is less than the weight of Y. This may be true, but the mass part is not true. The mass of X is less than the mass of Y. Yes, it's true. Both objects have the same weight. It cannot be true, because if they had the same weight, it means they could be extended by the same magnitude. Let's look at D. The mass of X is less than the mass of Y. True. The weight of X is less than the weight of Y. Yes. So the correct answer is supposed to be D. Why? Because the weight of a body depends on its mass. So if the object X has less mass, it also follows that it has less weight. That's why it has not extended. That's why X has not extended as much as Y has. Okay, that's very good. Then we move on to number 3. Number 3 is saying a plastic bottle contains 750 cubic centimeters of oil. Okay, the diagram shows the mass of the bottle being measured when it is full and then when it is empty. So when it is full, it has a mass of 650 grams. When it is empty, it has a mass of 50 grams. What is the density of the oil? Okay, now remember that to calculate density of a substance is equal to its mass divided by volume. Okay, so in this case, we needed to know the mass of the oil only. So to find the mass of the oil only, we must subtract the mass of the oil and bottle minus the mass of the bottle only. So in this case, it will be 650. 650 minus 50. Then we divide this by the volume, which is 750. So 650 subtract 50 is 600. Then we divide the answer by the volume, which is 750. So dividing the volume by 750, it gives us 0.8. 0.8. That means the answer to the question is A. The answer is A. So it's a bit involving. Don't forget, to find the mass of the oil, you have to subtract the mass of the oil and the bottle together minus the mass of the bottle, which is 600. Then you divide the answer by 750, which is the volume. Okay, considering that the mass of the density of a substance is its density divided by, its mass divided by its volume. All right, number 4, we are told that the extension load graph for a spring is shown. Then stretched length of the spring is 15 centimeters. Okay, so we have this graph here. So we have extension, which is plotted on the y-axis, and the weight or load in the x-axis. All right, so when the object of unknown weight is suspended on the spring, the length of the spring is 16.4. Okay, but remember that the unstretched length is 15. But the stretched length is 16.4. Already you can see that the extension E is 16.4 subtract 15, which is 1.4. So the extension is 1.4. Okay, the extension is 1.4. What is the weight of the object? What is the weight of the object? All right, so in order to find the weight, we needed to apply Hooke's law. We need to apply Hooke's law, and the Hooke's law says that Hooke's this law says that the force on a spring is equal to the spring constant multiplied by the extension. So in this case, it means we are required to find the force or the weight. This force here is the weight. Okay? So from the graph, we need to work out the spring constant. The spring constant. So the spring constant can be obtained from the graph by simply finding the gradient of the graph. The gradient of the graph. We need to find the gradient of the graph. So to find the gradient of the graph, we shall simply take the gradient of the line. Let us find the gradient of the line, this line, up to that point. Okay? So if we take this portion of the graph to find the gradient, we need to take the change in the extension divided by the change in the load. So the gradient is going to be the change in extension divided by the change in load. Sorry about that. Divided by the change in load. Okay. For which extension is the change in extension is going to be 2 minus 0 divided by 5 minus 0, which is 0.4. That's 2 over 5, that's 0.4. Okay, so from this, remember that the spring constant, if you're given, if your graph is extension against load, spring constant needs to be the constant needs to be the reciprocal of the gradient. So the reciprocal of the gradient, in this case, we take the reciprocal of the gradient, it will be, we are saying K is going to be 1 over the gradient. Why 1 over the gradient? Because the spring constant usually is supposed to be load over extension. But here we found the gradient of extension over load. So in this case it will be 1 over 2 over 5, which is the same as 5 over 2, which is 2.5. So then you go ahead to substitute 2.5 into the equation. So 2.5, we have 2.5 for K multiplied by the extension that we found earlier on. Remember that the extension was 1.4. So we multiply these two, 1.4. So 2.5 multiplied by 1.4, 2.5 multiplied by 1.4, gives us 3.5. So the answer to the question is C. I hope you have followed this. If not, just raise a hand and just tell me in the comment section. I'll be glad to explain this to you again. Question number 5. A student determines the position of the center of gravity of a piece of card. The diagram shows the arrangement that is suitable. The equipment that is suitable. The equipment is not drawn to scale. Alright, so we have a clamp on stand, a pin, a light weight on the thin string, a pencil, a stopwatch, and the card. Alright, remember the center of mass is simply a point on a body, a point on the body on which all the mass of a body seems to be concentrated. That's center of mass. Okay, so in order to do that, you shall need the clamp is needed. So let's see. The clamp is needed. Yes, clamp we need it. Pin, yes, is needed. Weight on this, yes, needed. Pencil, yes. And the card, yes. But the stopwatch is not. Okay, if you recall your experiment, remember that you shall need the pin to make a hole. Make a hole on the card, all right? And then you shall need the weight on a string to make what is called a plumb line. And you shall need a pencil to draw lines to show the point of the intersection between the lines drawn on the card. Okay, but you will not need a stopwatch. Okay, because this is not an oscillation in which you may need a stopwatch, so you will not need a stopwatch. So the answer therefore is D. All right, number 6. A cyclist stops the bicycle using the brakes. Which row about energy stores is correct? Okay, so as the cyclist is stopping the motorbike or the bicycle using brakes, okay, energy changes. Before it stops, kinetic energy is high. So kinetic energy is high. When it stops, kinetic energy is low. Remember, kinetic energy is energy of motion. Okay. All right. So, we are asked to say which law about energy stores is correct. Part A is saying kinetic energy store of a bicycle decreases. Yes. Chemical energy store of brakes increases. Okay. B, kinetic energy store of bicycle decreases. Yes. Thermal energy store of the brakes increases. Thermal energy store of body of brakes decreases. Kinetic energy store of bicycle increases. Thermal energy store of brakes decreases. chemical energy store of the bicycle increases. All right, so in this case, the correct answer would be B, because kinetic energy decreases, yes, but because of the brakes, there's friction between the tires and the road surface. That means thermal heat energy due to friction increases. So the answer is B. Is B. All right. But question 7. A man applies a force of 40 newtons to push a box along the floor, right? Okay, how much power is required to push the box 4 meters in 3 seconds? Remember that power is equal to work done divided by time. Okay. So work done is the same as force times distance, and the time, and then you divide this by time. Okay. So the force applied is the force. So about that, the force applied is 40 newtons. 40 newtons. The distance moved is 4, and the time taken is 3 seconds. Okay, so computing this, you have 4 or 40 multiplied by 4 divided by 3. The answer is coming up to 53 watts. So obviously the answer is going to be C. Just to remember the formula for power. Power is work done divided by time taken. All right, question number 8. For identical submarines, P, Q, R, and S are lowered from one depth to another in water of constant density. The initial and final depths of each submarine are shown as in the diagram. Okay, so we have a submarine, submarine P. Submarine P initially was at a depth of 10, and then it goes down to a depth of 30. Okay. Then Q initially was at 50, this one, and finally at 70. R was at 10 again, and finally at 50, and so on. S was at 30, and finally at 70. Okay, so let's look at the question. What is the question saying? The question is saying which row is correct for the difference in pressure from the initial to the final depth of each submarine. Okay, so remember that liquid pressure depends on the depth. So for each submarine, we can work out the depth. The one that has a pressure, a large depth different, it means we'll experience a much larger difference in pressure. So for P, the pressure difference is 20. This is 20. It's obtained by subtracting 30 minus 10. Okay. So we do the same for others. P and Q. Q is also Q will be 70, subtract 50, which is also 20. Okay. R is at 50. R is at 50. R is at 50. Over here, 50. And then this one is 10. So we subtract 50, subtract 10. It's 40. This is 40. And then lastly, S is at 70. S at 70. Finally, initial at 30. Pressure difference, height, depth difference is also 40. Okay, so let's look at the details of the question. Least change in liquid pressure. Least change will be P and Q. Yes, because the difference in depth for P and Q are the same, which is 20. Therefore, they will have least pressure. And the greatest change in pressure is R and S. Both of them have the same depth difference. So the answer, most obviously, is going to be A. All right. Number 9. Number 9. Some terms describing changes of state are listed. Okay. Remember that matter can change from one form to another. So we have boiling, solidification, condensation, and evaporation. Okay. What does the question say? Which two terms identify the same change of state? Okay. If you look at boiling is changing from liquid to vapor. Solidifying is changing from liquid to solid. Condensation is changing from gas to liquid. Evaporation is also changing from liquid to vapor. That means 1 and 4. So the answer will be B. Because boiling involves change of liquid from liquid to vapor as well as evaporation. So these are basically talking about the same change. All right. Number 10. The diagram shows apparatus. The diagram shows apparatus being used to observe smoke particles. Diagram 2 shows how smoke particles moves. A small particle moves randomly here. Okay. Why do the smoke particles move randomly? Okay. So let's look at the available options. They are hit by air particles. Okay. They are less dense than air. Okay. They are moved by conventional currents. Okay. They gain kinetic energy. Okay. So usually the smoke is a solid. You need to know that it's not a gas. It's something. Okay. So when mixed with air, it means the movement of the particles will be in response to the movement of air particles, which are always in random motion. Okay. So In this case, the reason why they're moving randomly is because they are hit by air particles which are already moving randomly. Okay. Number 11. How is temperature in degrees Celsius converted to temperature in kelvins? Okay. Remember that temperature in kelvins is simply temperature is equal to temperature in kelvins is equal to temperature in degrees Celsius plus 273. So the question is, how do we change temperature in degrees Celsius to kelvins? So just solve for temperature in degrees Celsius. Now make it the subject of the formula. So it will be temperature in degrees Celsius will be equal to temperature in kelvins, subtract 273. So in this case, we subtract 273 from temperature in degrees Celsius. That means it's D. The answer is D. All right, so for the time being, I would like to stop here. Then we continue in part 2, where we are going to look at the rest of the questions. My name is Mr. Pochilola once again. Wishing you all the best. Consider subscribing to the channel so that every time I upload a video, you are the first one to know. And also inform your friends that it is possible to come on this platform and revise, especially for the October-November exams which are coming this year. Thank you very much for your attention. Bye-bye for now.